So far we have seen how inference works through model checking and sound inference rules. But here's a big question. Can one single inference rule be both sound and complete? The answer is yes. And that rule is called resolution. So we'll see how resolution works, why it's powerful, and how it becomes the basis for automatic theorem proving, used even in today's SAT solvers and AI reasoning systems. So earlier we saw the inference rule like modus ponens are sound, but not necessarily complete. That means they will never tell you something false, but they might miss some truths. So when they entail from the knowledge base, they will not entail anything which is false, but they might not entail some truths. That means they might miss some of them. Resolution fixes this. It's a single, simple rule that when combined with systematic search can derive everything that's true in propositional logic. So resolution gives us a complete inference system. If something can be proved from the knowledge base, resolution will find it. So that's very important, okay? So we have already shown some example of resolution for rule 16 and 17 when we proved the Wumpus world case that if there is no pit in 1-1 or 2-2, the only remaining place is 3-1. And we have shown that by step-by-step resolution. So what exactly is resolution? Formally, resolution works on clauses, sentences written as disjunction of literals, like P or Q or not R. So this is a resolution. A clause, okay? Sentences written as disjunction of literals. Whenever two clauses contain complementary literals, say one P and the other one not P, you can combine them, cancel those literals, and produce a new clause. So example is clause 1 P or Q and clause 2 is not P or R. So here P and not P are like opposite literals, complementary literals. So after resolution, the resolvent will be P or R. Q or R, because P and not P will be cancelled. So that means, as I said, whenever two clauses contain complementary literals, say one P and another not P, like here clause 1 and 2, you can combine them, cancel those literals, and produce a new clause. That's resolution rule. It looks simple, but it's powerful because it systematically eliminates contradictions until we either prove the goal or show it's not entailed. But how we do that? So those are the resolution steps, okay? So we will see that. So how a resolution-based inference actually works. To prove KB entails alpha, so there are two steps, okay? The first step, we must express every sentence in a standard form called conjunctive normal form, okay? So there will be multiple clauses connected with and or conjunction, and inside those clauses there will be many different literals which are connected with or disjunction. So that's the first step. You have to convert the clause in conjunctive normal form, and then a sentence in CNF. Okay, so to prove KB entails alpha, we try to show that KB and not alpha leads to a contradiction. That's called proof by contradiction. So you see, we want to prove alpha. We are trying to show not alpha is can be ANDed with the knowledge base or not. And finally, we'll find that there is an empty clause. If we find an empty clause, then we will know that no, that not alpha is false. So that means alpha will be true. That means KB will entail alpha. So the process goes like this: convert KB and not alpha into CNF. Repeatedly apply the resolution rule between pairs of clauses. Okay, multiple time you can try to combine them, see that where there is a complementary literal, can it be cancelled even with the resolved part, or like we said here, resolvent, we can try to do another clause, okay, and see if there is any more further resolution can be done. So repeatedly you can apply between pairs of clauses. If at any point we get an empty clause, which is represented with an empty box or square, a disjunction, so empty square is basically a disjunction or connected, no literals. So no literals means they are kind of 0 or false. So if everything is false, that means what we are trying to show, kb and not alpha, is false. That means alpha is true. That's the logic. Okay, so that means we have reached the contradiction and alpha is true. Hence, kb entails alpha. So that's the idea. So now resolution may sound a little bit complicated. So we need to kind of show that how resolution works, and we can show it with an example. But before that, so we want to say one more time what makes resolution special. It's sound. Okay, it never lies. Whatever it deduces from the knowledge base is true. It's complete. That means it can find every truth, which other rules, individual inference rules, were not complete. And it's systematic, okay, easy for a computer to automate step by step. This single rule forms the basis of modern logic-based AI systems, from theorem provers to SAT, okay, SAT, which is the this is a format like the CNF, or conjunctive normal form. So SAT solvers to constraint solvers used in scheduling, verification, even reasoning in knowledge graphs. Okay, so in summary, resolution is one rule for sound and complete reasoning, and works via contradiction. Okay, kb and not alpha, you have to show that creates a one null clause. And it works by CNF conversion. Okay, without a CNF form, it will not work. And then it's the foundation of the modern logical AI-based systems. Now let's see an example. I'll solve this example and show how it works.